This is a very simple case of the inclusion exclusion principle. So the idea here is we've got a sports club and there are 25 members. So capital M is going to be the set of members and little m is the size of that set, which is 25. So that's information that we're given. And in the sports club you can either play tennis or you can play squash, or if you like you can play both. And in fact there's some members who don't play either, they just go there to drink at the bar. Okay, so we're given again that there are 10 people who play tennis. So we're going to write capital M subscript T for the set of members playing tennis, and then little m subscript t is the size of that set, which is 10. So that's again information that we've been given. And similarly for squash, we're told that there are 12 people who play squash. So capital MS, that's the set of members who play squash, and little ms is the size of that set, which is 12. Then we can think about the members who play both tennis and squash. Okay, so that's written capital M subscript TS for the set of members who play tennis and squash. Again, little m TS is the size of that set, and we're given that the size of that set is 3. There are 3 members who play both tennis and squash. So next, it's easy to work out the number of people who only play tennis. Okay, so the set of people who only play tennis is going to be called MT star, people who play tennis only. And that's MT, the people who play tennis, and then we remove MTS, the people who play both tennis and squash. And so little MT star, that's the size of that set. So that's the number of people who play tennis minus the number of people who play both tennis and squash. 10 minus 3 is 7. Okay, so in this Venn diagram here, we've got 7 in this region here. These are the people who play only tennis. 3 people here who play both tennis and squash. So together that's 10 people playing tennis. And similarly for squash, MS star is the people who play only squash. The number of those is the 12 people who play squash minus the 3 people who play both tennis and squash, and that's 9. Okay, so we've got 9 people in this region, 3 in that region, 7 in that region. Okay, so if we look at the number of members who play some sport, okay, that's a disjoint union of 3 sets. There's MT star, the people who only play tennis, MS star, the people who only play squash, MTS star, the people who play both. And so we add up those 3 numbers, 7 and 3 and 9, and we get 19 people who play some sport. But it's useful to note that there's some kind of cancellation going on if we look back at the formulas we've already got. So MT star was MT minus MTS, MS star was MS minus MTS, and then we've got MT plus an MTS. So one of these minus MTS's cancels with a plus MTS, and what we get is MT plus MS minus MTS. Or another way to think about it is we take MT plus MS, that's the people who play tennis plus the people who play squash, but if we just take this combination, then the people who play both tennis and squash get counted twice, so we have to counteract that by subtracting MTS to get the total number of people who play either tennis or squash. And now finally we can work out the number of people on the outside who don't play any sport at all. So that's the set of members here, and then we remove the union of MT and MS. So M star is the number of these people. Okay, so we noted that the size of MT union MS was MT plus MS minus MTS. And so when we subtract that off from M, we get M minus MT minus MS plus MTS, which is 6. And notice here we've got M with no subscripts with a plus, MT and MS with 1 subscript with a minus, and MTS with 2 subscripts with a plus. Okay, so that's going to be a pattern that we'll see works more generally.